Hi. My name is Chris Weyl, and I'm absolutely terrified to be standing in front of all of you today. But I want to talk about metaprogramming, which is something that I find rather fun, actually. First, I should say thank you to DreamHost for sending me here today. We do some pretty cool stuff. Check us out. So the abstract we put in says that we'll talk about a number of things. What a mop is, what mops are available, why would we want to modify a metaclass, what tools we have to work with metaclasses. Thankfully, we don't need to talk too much about the first two because Apsana talked about those in the last one. So this is a bit of a pragmatic approach. I've been working with metaclass traits for longer than I really care to admit to. In large part because I find them fun to write and they're fairly relaxing. And you can do some fairly cool things with them. But why would you want to modify a metaclass? I might actually be insane. But first, let's talk a little bit about a meta-object protocol versus a metaclass. Mops set expectations. A class may have 0 more attributes. It'll have a certain number of methods. You can manipulate these things using additional methods off of a metaclass. A metaclass implements the mop in certain behaviors. How attribute accessors will be installed, for instance, or what options to attributes constructors will be accepted. Traits modify those behaviors. For instance, you can modify a class metaclass such that all attributes created off of that class will have different traits applied to them as well, or add entirely new ones. I don't know why you'd want to put purple attributes in there, but you can. Metaclasses are the rules, basically, and sometimes we want to change the rules. I was trying to think of examples to talk about, and one human example came to mind. My grandmother lived in Allentown, Pennsylvania for probably close to 60 years. She loved to play bridge, but was very hard of hearing. After living in the same place for 60 years and playing bridge on a regular basis, there are some people who are going to come up to you and talk to you, and she didn't like to talk to everyone, but you can't just ignore them. So it took me a long time to figure this out, but she'd casually reach up and scratch her ear, and turn off her hearing aid. Now, this allows the human mop to be honored. We have ears, we're hearing, everything along those lines, but the hearing aid is a trait that was applied that allows us to control the volume of what we're hearing directly. Another good example would be that we want to introduce additional options for attribute construction. Lazy build. I used to really like lazy build. I don't know if anyone's familiar with it anymore, but lazy build was an option to attributes in Moose for the longest time, and it just set a whole bunch of different values to predictable things. It set clears to be clear underscore attribute name. Builders were always underscore build underscore attribute name, bits along those lines. Then we were not supposed to use that anymore. But that behavior is still pretty useful. So you can actually so I wrote a little trait called attribute shortcuts out there that allows one to do just that and a bit more. Builder 1, clear 1, predicate 1, those are all understood now. And this is done by actual metaclass manipulation instead of by changing the way process options happens inside the attribute metaclass versus changing things on the front end, trying to rejigger has or something along those lines. There are a whole slew. There are more metaclasses out there than one really thinks of inside Moose. The ones that were that I found the most reason to modify would be attribute metaclass, by and far. Roles don't actually have attributes until they're applied to something, so they have applied attribute metaclasses as well. And the role class metaclasses. There's additionally instance mops out there, instance metaclasses, some other bits along those lines, type constraints. So there are a number of tools that we have, a number of ways that we have to modify metaclasses. One is to just do it outright, swap, put in a different metaclass, something perhaps that you've built on your own with methods or additional traits composed in on top of that. A good example here of when you'd actually want to do that would be if you're implementing a new type constraint or something along those lines, because you are creating new behavior, but you're also creating in its own right a legitimate new metaclass. The most common and accepted ways to modify your metaclass behavior is to use traits. They're just roles just applied to your metaclasses instead of to your classes. I can never find a good consistent definition of traits either. Like, a lot of people in papers like to say traits, but we use the word roles for that unless we don't. So I tend to think of traits as being meta roles, or roles that we'd apply to a metaclass. We can pretty much do anything we want in traits. When we're working with them, we're working with Perl. We're also working with the full power of Moose, because that's already been bootstrapped. We, however, do not want to modify the behavior in such a way that violates the mop. If trying to work Vincent van Gogh in there, but that's probably not a good idea to talk about my grandmom losing an ear. If all of a sudden, if you applied a trait to a attribute or to a class metaclass that took out some of the, or altered irreparably some of the functionality relating to, say, creating associated attributes, that would be incredibly surprising. That would not be a good way of changing the rules here. So traits are really pretty easy. Let's write one. Whoops. Create a new little package.
Could you increase the text size on the terminal?
What's that?
Could you increase the text size on the terminal?
Oh.
Thanks.
Like you actually want to read it. Now I have to do something. How's that?
That's good.
Better? Okay, awesome. So I've created a little Frobnip distribution. That seems to stick in my mind more than foobar. I have no idea. Let's create... All right, that's a trait. Admittedly, not one that does terribly much or anything at all. It's just a role. Traits are really well, they're best seen in their application versus anything else. What I just garbled saying there was that they look like roles. They are just roles. If we look at here, we've just applied that, or rather, we've caused the Frobnip trait to be applied to the attribute foo inside this particular package. There's a number of different ways to cause attribute traits in particular to be applied. One of them is to do it in a one-off way like this. Another way would be to use Moose Exporter, which we'll go into in a little bit, to cause the actual the name of the metaclass, the name of the attribute metaclass associated with this class is metaclass's instance to be changed to include a subclass of moose meta attribute that includes the frobnip trait already composed in. So we can test that. There you go. Test Moose More is a package that makes it easy to validate structural bits about your Moose classes. Here, for instance, we're validating the class and seeing that, indeed, frobnip does have a metaclass and it's a Moose class and has an attribute named foo. But we're going deeper and we're looking at the metaclass instance associated, the metaclass instance for the attribute foo inside class frobnip and checking it out as well. It's the metaclass in there is just another moose class, but we see it does indeed do the frobnip trait. I need to come up with a better name than frobnip. You can also apply traits pretty easily or on the fly to a actual class, though I can never remember if it's dash traits or not. No, that's going to test that. Anyways. So, trait application. Yep. The way metaclasses are composed, if you make changes along these lines to the metaclass of a parent class and then you descend from that class, any changes you've made structurally to the metaclass of the parent class will be composed into the metaclass of your new class, of your child class. So basically, if you use something along the lines of attribute shortcuts, and or not. Interesting. All right. So if we look over here, we see that we're applying a number of roles or traits to metaclasses. These will propagate as well. If we, inside our new class, that now that it's so big I can't find, there we are. So let's say we use that there. Using this, because of the Moose exporter setup, will cause a certain trait to be applied to foo. this one. Cool. So we can see
Could you bounce your font up just maybe one or two?
sorry?
Could you bounce your font up maybe just one or two steps?
No problem. There we go. There we go. So we see that that's in there, and if we were to subclass, that'll take forever. How about we just say that when you do that, when you subclass it, you can validate, you can see that it'll show up. So there's some things to remember. There's actually a surprising number of tools that make manipulations like this easier. When you're working with creating metaclass traits, all of Moose is available to you. If you've ever looked inside the class of class mop class, there's a lot of incredibly clever stuff going on inside there that we don't ever need to do anything along the lines of, because the mop has already been bootstrapped. There's no reason to try to wiggle around not being able to create or attach attributes, because we can create and attach attributes directly. Play nicely with others. Yes. Using Morse exporter is a good way to play nicely with others. It will help keep you from stomping on other attributes. It will cause multiple traits to be composed into your metaclass instances in a way that isn't very breaky and just works. So use traits as roles, not full metaclasses. It is possible to specify a custom metaclass, either when using Moose and have that be applied, be used as the metaclass for your class itself, or like when creating attributes, bits along those lines. However, that makes it very difficult for the built-in systems inside Moose to be able to, compose new traits into your these metaclasses down the line, which does come into play, especially if there are a number of additional people extending your classes or using them. Just don't do that. If you modify methods, then you don't necessarily stomp on the behavior that some other trait has put in there. Even if you don't know of any other trait using something or doing something to the method that you're overriding, doesn't mean that there isn't, or that someone won't try to at some point. You don't need to create your own metaclasses and whatnot. Moose Exporter does really make it significantly easier along these lines. Let's take a look at curried delegation. So to curry something is to basically take a more generic function and build more specific functions off of it by sticking additional parameters in the front each time, right? So being able to curry delegated methods from an attribute could be useful. I thought it was useful, but I'd had a stressful weekend and needed to write something to relax. So here we see Moose Exporter doing, this is all we need to do to cause certain traits to be applied. Trait aliases just creates basically a constant sub inside whatever package is using MooseX curried delegation that contains the name of the trait. That's also another great way of playing nicely with others. There's some tricks that you can do with package names and certain namespaces to cause Moose to try to look up a trait, the right package for a trait, but that's just kind of painful. Moose Exporter allows us to export certain methods either as is, just like exporter, or well, we don't see it here, but with meta, which will include the actual metaclass instance of the class that this is being imported into. That's how has, for instance, uses how it gets a hold of the metaclass in order to be able to create attributes inside that class. Class meta rules and role meta rules. This is actually right out of another package, museutil meta roles, where you're allowed to specify traits, roles to be applied to different metaclasses when this is used. It's just, I'm struggling to find a way to say anything more than it's easy and works. But this is the sort of thing that just is kind of easy and works. So now here we see that when this is being used inside of a class, the attribute metaclass has this trait applied to it, the trait attribute. And the applied attribute has this as well inside of a role metaclass. Roles, again, their attributes aren't actually created until they're applied, so putting it under applied attribute is basically the same as class meta roles for class. Inside our attribute trait, we see it working around and overriding a number of methods, creating a new one. You'll often need to do things like this, make delegation method inside of an attribute, because that's what controls certain types of methods, in this case, delegation methods being written out to the associated class. Process options is another one that often gets overridden or altered. It's very important to just wrap these. We're playing with what's ostensibly a private function here, right? A private method. But at the same time, you're changing the private and public behavior of this given attribute metaclass. So it's actually appropriate and okay to be doing that. Here we are saying that we have a new type of metaclass for a method. And it's just the same as the existing delegation method metaclass, but with our trait applied. And whenever we're told to create the delegation methods inside the associated class, we also go through there and we do our check to see if, in this case, someone's used a hash ref to define a delegated method. And we know to handle that and let everything else pass through to the previous class, the original method. And then inside our method metaclass trait, we have an attribute out there that just kind of hangs on to stuff. And we do actually override the initialized body method here and use it to set up a curried code ref. So 3 classes, 2 traits, a couple overridden functions, and all of a sudden our attributes know how to handle curried method delegation. Yep. That stuff is cool, I think. Yeah. So there's a number of tools out there that help. We've seen testmoose more a little bit. That helps validate what's going on when we're making changes along these lines. Someone said at dinner the other night, other languages try to protect the programmer from themselves. Perl kind of gives you a loaded gun and says, go have fun. So you have a lot of bullets here, basically, if you're not careful. So we've looked at moosex curried delegation already. Another example of an attribute trait would be moosex autodestruct. Now this one is good for, let's say you have a value that's expensive to generate. So you'd want to, say, set it up as a lazily built attribute on top of a class. It's expensive to generate, but it's only good for a certain amount of time. How do you handle that? You could do it manually, working around things, or you could create an attribute trait that allows you to say to the attribute, this is only going to be good for another 300 seconds or so. If I ask for this again after that point, don't give it to me. Clear it, pretend it was never there, and rerun the builder method. There we are. One of the joys of dealing with internal methods and behaviors is that stuff does change from time to time. So sometimes you do need to check. Not often, but sometimes. So here we have our exporter being set up. Our trait alias is in place. Whoa, and apparently I did this long enough ago that I actually used the old way of looking up traits. If you pass a bare word in, just autodestruct, for instance, to an attribute, Moose will look to see if it knows about that in its internal registry, and then it'll look for a package in the Moose meta attribute custom trait namespace. As you can imagine, the potential for conflict it's there. And then it'll call a register implementation and get the actual name back. At some point, I should fix this to stop doing that. There we are. And here again, we are working around v1 versus v2 differences in Moose and applying the right attribute. All right. So when this is applied, our attribute metaclasses will now understand and have time to live information kept. So we had also alter things slightly. Normally, the instance metaclass for a class allocates one slot to an attribute for storing its value. Here, though, we're going to use two slots. We'll have the slot that we're putting the value in, and then the time we've just calculated that the value should die in at. We're wrapping the slots method to add our destruct.slot, so everything just works along those lines. Everything that manipulates slots, that is, inside an attribute just works. Some methods to help us set when they should die, including using the meta instance to set the slot values and whatnot. There's a package out there. I forget the name of it, but it's an instance metaclass, and it allows one to turn your Moose objects into inside-out objects just by changing a number of things. The mop is honored, set slot value, get slot value, all of those things still work, still exist, but behind the scenes, it does something entirely different than the default instance metaclass. I like that. See if we have a doomsday, our doomsday value, avert doomsday, and then we override a number of different methods. To set when it should blow up, or to reset when it should blow up. Clearing a value clearly averts doomsday. Getting has whatnot. And enforce doomsday, all we do, there it is. If it's doomsday, just clear it. And at that point, it goes back to the normal getter methodology and says, oh, hey, there's nothing there. I'm just going to call the builder again. Working with attribute traits, if you're doing bits along these lines, sometimes you will need to mess with with method inlining. It's basically a string eval to create methods associated with attributes inside of a given class, for instance. Everything at the moose level is inlined. Everything at the class mop level, it's an option of whether it would be inlined or not inlined. Theoretically, not theoretically, but the inlined version is faster, which is why at the moose level it's all inlined. Although I have no idea actually if the improvements in 5.24 have changed that or made it worth it. So there's that. So we're really talking about traits right now and modifying metaclasses, but it's totally possible to do a certain level of metaprogramming without using traits at all. There's a package, MooseX related classes, that builds a custom role using another package, MooseX role parameterized, and then applies them based off of what, something you've told, the parameters that you've given it. Trait method, attribute shortcuts. Here we are. So inside our related classes package, see the standard imports. We're using MooseX role parameterized instead of moose role. We're using moose exporter and telling it how to set up our import methods. 3 additional methods, we're going to export, but with the meta class associated with it, so that we can use that to generate our custom role, and then apply it right off the bat to the given class. In this case, when we're finding the meta of MooseX related classes, that's the meta instance of our package here. You tell that package to apply to another package, either a role or a class. And because we're using a parameterized role, we can actually pass a number of options through. Parameterized roles, parameters are basically just a special variant of an attribute. And then inside your role block is where your actual role lives. And you can access the parameters and your own meta class while creating the meta class of a role that's custom designed based off of the parameters you've set. So, for instance, this particular package, depending on what you do, will generate a whole bunch of additional attributes. And we're using the meta classes. We're manipulating bits along those lines, but we're not actually modifying any of the meta classes. So, any questions? I recognize there's a lot of different bits out there, a lot of moving parts. So.
The MooseX auto destruct that you were reviewing is the one that's actually in CPAN. Right?
Auto destruct is up on the CPAN.
The code that you were reviewing is in fact what's on CPAN right now?
Yeah.
Okay.
Cool. Well, thank you.